Okay, we're back again. LeetCode 121 this time. Grind 75 number 4. Best time to buy and sell a stock. So basically, you're given an array, and every entry in the array represents a price, and the index at which the price occurs represents the day. So for example, on day 0, the price is 7. On day 1, the price is 1. On day 2, the price is 5, and so on. And your job is to basically find the maximum profit that you can generate by buying a stock on some day and then selling it at a later date. Now, the first solution that I should mention, it's going to be an n squared solution. It's basically you take every single price. So like let's say you consider 7 as like your buying price. And you calculate all the profits you can get by selling on these days, and you do the same for this and this and this and this, and you're going to update your max profit that way. But we're not going to even bother with that attempt. I think it's better to just jump into the O of n solution, which uses a two-pointer method. And I've prepared something here in Paint, as always. And so this is a graph. This is a visual representation of the data we're given. It basically shows how the prices change throughout the days. And basically, what the question asks is we want to maximize our profit. Well, what is our profit? Like, what does it mean to have a profit? Well, we know that the profit P is going to equal to whatever you sell at minus whatever you bought at, right? So how do we maximize this? So let's say like we sold at 5. What would we have to subtract from this to make this the biggest it can be, right? Well, ideally, you'd want 0, right? You want to get a stock for free, and then you want to sell it when it goes up, which gives you a profit of 5. But like if we bought at 5 and then we sold at 5, right? It's gonna be 5 minus 5. That's gonna be no profit. If we if we sold at 5 but bought at 4, that's 1 profit. So the idea is we want to minimize this variable right here, like what we bought at. And how we're gonna do that is actually pretty simple. We're gonna initialize 2 pointers. So one of them is going to be the left pointer, and the other one's going to be the right pointer. And for now, I think we can get away by initializing them both to 0. Now, what the left pointer is going to symbolize is the price at which you bought something at, and the right pointer is going to symbolize the point at which you sold something. And by calculating that difference, we're going to calculate our profit. But there's a little bit more to it. We're going to, oh, sorry, I didn't mean to do that. We're going to have a little bit of logic for how we determine which pointer gets to move where. And to start this off, I'm gonna initialize a couple things. So I'm gonna say, let's say we have a variable called lowest buy, and we're gonna say that the lowest buy is gonna be prices at 0, which conveniently is also equal to our current L, right? So the lowest that we know of, the lowest price for a stock that we know of right now is 7. I'm also going to have like another variable that I'm going to say is our max profit. Well, since both L and R are at 0, right? If we buy at 7 and we sell at 7, our max profit is going to be 0. So we're going to start that off with 0. So we'll do this. So let's now dive into the logic for our pointers. So I think what I'm going to do is I'm going to have my right pointer, which is going to be like my scout, always move ahead and travel forward until it reaches the end. But as it travels along, I'm going to ask a couple questions of this pointer. So I'm going to say, hey, right pointer, you just moved. Is the price that you're at by any chance, is that lower than our current lowest possible buy price? Because we know, for instance, like we know this is equal to 7 right now, right? Because we're here. So we're assuming that we're buying at 7, but right tells me, oh yeah, well, I'm actually at price 1. You should actually buy at price 1 instead. So what I'm going to do is going to have my left pointer move here, right? So my lowest price now becomes 1, right? And so my right pointer did its job, and my right pointer gets to move ahead. My left pointer is here now. My right pointer looks at day 2, and it sees a price of 5. It asks again, hey, we ask it again, hey, is the price that you're seeing, is it lower than the current lowest thing we can buy at? And it's gonna say no, it's a 5. Our current lowest is a 1. So we say, okay, that's fine. But what about a profit? Can we make a profit? Well, we say, well, 5. If I sold at 5 minus 1, well, that's 4. So my max profit right now is actually $4 or whatever units you want to use. Again, right gets to move forward. Right looks and it says, cool. We're at day 3. We ask the same question. Hey, is the price at day 3, is it lower than our lowest buy price? No, it's at 3. Our lowest is at 1, so we don't do anything. But we do check the profit. 3 minus 1 is 2. But we already see that our max profit is 4. So we just don't do anything, right? We don't have to do anything. So we move along. And we see that our right pointer is now pointing to day 4. The price at day 4 is 6. And we say, okay, well, are you lower than the lowest buy price? No, we're not. So let's calculate the profit. The profit becomes 6 minus 1, which is 5, which is bigger than what we have now. So we get a 5. Cool. Finally, we move on to the last day, day 5 or 6, because we're 0 indexed. Doesn't really matter. So we're at day 5. We see a price of 4. We again ask the same question. Are you lowest than the lowest buy price? We're not lower, so we don't get to update it. We keep it as 1. But we do calculate what profit we can generate. 4 minus 1 is going to be 3. 3 is not bigger than 5. And eventually our loop is done because we went through all of the prices, and we're left with a profit of 5, and that is our final result. Pretty simple problem. Let's code it up. Okay. So to get started, I'm going to say that int L, I think, should be equal to 0. And then our max profit is also going to be equal to 0, as we talked about. And then we're going to just have a for loop to move our right pointer, right? Because the right pointer is the one that always gets to move. So it's pretty nice to just have it automatically get incremented by a for loop. So we do int r equals 0, while r is less than prices.size, if I can spell today, and then we just increment it. And right away, as we said earlier, we're going to have our right pointer is always going to respond back by telling us if the thing that the right is seeing is lower than our lowest price. So we say if the prices at R, if it's less than the prices at L, right? And then what we're going to do is we're going to set left to be R because we found a new lowest price. So we can just comment that. We found a new lowest buy price. Cool. Else, what we're going to do is we're going to say max profit is going to equal to the maximum of prices at which we sold minus the prices at which we bought compared to the already existing max profit, right? Because that's how we update our max profit. And then once we're done with this for loop, once it's finished, ideally we should be able to return the maximum profit that we can generate. So let's see if this runs. There we go, it works. Let's put in the other example case. It works too, awesome. Let's submit this, and there we go, it runs. It's 72% faster, but this fluctuates, so whatever. And there you have it. Pretty easy problem once you know to use two pointers. I think using two pointers is a pretty good technique for all these types of like linear scan problems. Um, but yeah, that's all there is to it. I hope this helped.